Good morning, Melbourne. Hi, my name is Isuru. I'm a senior Android developer at Motorola Solutions. And I actually wanted to do a version of this talk 3 months ago, as she mentioned, but I didn't run out of time. But here we are 3 months later, looking at a Halloween-themed presentation, I guess. But before I do start, I want to give a huge round of thanks for all the sponsors and also all the volunteers and the organizers down here. And also thank you for voting for my talk. I actually wanted to, this is sort of an extension of a talk I done. Actually, before I forget, there's also bingo downstairs apparently, so go take your stamps and get the free stuff. All right, so this presentation is going to be about design patterns, and more specifically, the object-oriented design patterns. You might have heard about them, so I want to give a little bit of context before I jump right in. So this is based on a book that came up about 30 years ago called The Gang of Four Design Patterns book. The actual title of the book is something different, but it's too long. I'm not going to say that out loud. It came out in 1994, and it was based on, it's written in the context of C++ and Smalltalk, but it's actually widely adopted by a Java community a lot, and as a consequence, I get to experience it when they use Java to write Android SDK. Another thing about this presentation is that the actual book has these 3 different chapters. It talks about these design patterns in categories. There's creational design patterns, there's structural design patterns, and there's also behavioral design patterns. The creational is about creating objects, obviously. The structural is about how you structure your objects. And then finally, behavioral is about how to make the objects behave. So we can talk about those 3 pillars. The design patterns, one thing I want to point out here is that design patterns were actually introduced to solve a particular problem. So if you don't have the same problem, maybe you might not need the design pattern. And the context for this presentation is going to be Java. Well, more specifically, since we're sort of moving short from Java to Kotlin in Android world, the context is going to be how some of those design patterns sort of translate from Java to Kotlin. Again, if you look at the book, there's like 30 different design patterns. I can't count. Is that 30? Maybe. But we're not going to take a look at all of them. We're going to take a look at a few of them. Again, this is even still too much. So I guess this is time where you come in and I'm doing this whole haunted horror house theme. And it's like those Goosebumps books that you've read in the past where you can choose which door you want to go down. So if you want to learn about this behavioral design patterns, you can go down to the attic, go down to the cellar. And if you want to learn about the creational design patterns, we can go down to the kitchen. And if you want to learn about the structural design patterns, we can go up to the attic. I would recommend, actually, this is how you vote. Yeah, so you can scan in a QR code and, yep, sure, pull up your phones and scan for this QR code. Or you can also put in the code up there. Okay, we got a few people in here already. I'm going to go to the next page. The next page also has the same QR code. And you can click on place of this picture where you want to go. Hopefully there's only 60 people in this room because I didn't pay for the subscription. All right, so the votes are coming in. How are we doing for time? 5 minutes, that's good. Looks like everybody wants to go to the cellar. All right. Are we still voting? All right, I'm going to stop right before the 60 people joins in and realize there's a limit. All right, so it looks like we're going down to the cellar and learning about the behavioral design patterns. Okay, so this is actually an interactive presentation, so let's go down to the cellar and learn about some behavioral design patterns. And down in the cellar, we got a creepy-looking ghost on the side there trying to teach us the visitor pattern, and on the left, we have the state pattern. These 2 patterns are behavioral design patterns. It describes how objects behave dynamically or statically during runtime. Yeah, so which one do you want to explore? I'm going to go to the next one. It's actually the last one in the list. Yeah, so cast your vote on which design pattern you want to explore. Would it be the ghost? Looks like we're getting a lot of hits on the ghost. Ooh, no, the state pattern slightly overtook. Is it the ghost or is it the visitor? I don't know. Which one is it? Can't do the math. I think it's the state pattern people wants to listen, right? Okay, so if it's even, it's dealer's choice. I think visitor slightly has a more. Yeah, so I'm going to go with visitor. It's almost even, so let's do visitor. The visitor is the most fun. Okay, let's learn about the visitor pattern. So before we jump on to actually implementing the pattern on the book, I want to emphasize on what we're trying to solve in the first place. So I have a simple sample program. I'll go through all the code. I know this looks very scary. It's not intended. We'll go through line by line and explain what we're trying to solve. So here we have a simple class, a compartment class, and a number of compartments that could it be. Like for instance, could it be a kitchen, it could be a stair, it could be like a boiler, and it could be the bulkhead doors on the back there. And then we also have a container, like a room that has a number of compartments in it. By the way, you're looking at Java. I know that's also scary. We'll look at Kotlin code in a bit later. Down here, so for the sake of this argument, let's assume that we can't change too much stuff around this class. We can assume this is part of a library class that you're not allowed to touch. Down here, we have our visitor, in this case, a ghost. The ghost can haunt certain compartments. It can haunt the kitchen. So for instance, if you ask the ghost to haunt the kitchen, it'll rattle all the dishes. If you ask the ghost to haunt the stairs, it'll make the stairs go creak. Or if you ask the ghost to haunt the boiler, it'll make some clicking noise. And on top of that, if you ask the ghost to haunt the room, it'll try to go through all the rooms one by one and create a description of its haunting. The main program is also simple. What I'm doing here is I'm creating a basement and a kitchen and putting them together inside of a big room and then asking the ghost to haunt the room. Now, if I run this program, I'm expecting it to print something like that, where it will describe each description and one at a time. But when I run this program in JVM, I get that. Why could it be? Well, clickety-clicky. I pressed the wrong button, it went back. If I go back to the main previous program, what do you think? What do you guys think? What's going wrong here? In fact, if you look at here, this is the first time our haunt functions gets evaluated. And the IDE actually tells you what's wrong here. If you look at how the IDE is highlighting these sub-functions down there, it's telling me that, hey, no one's using these functions. Why is it there? It turns out this is because of a problem of the JVM called single dispatch. Because during static compilation time, the compiler doesn't know that you're trying to call these functions of the subtype. And instead, it's always reverting to the base type, which is the component. So without the visitor pattern, we are unable to dynamically add new behaviors to an object without sort of modifying its underlying structure. So let's see how we can use the visitor pattern to solve that exact problem. So according to the prescribed solution of the Gang of 4 book, this is the solution. You need two different interfaces, the visiting interface, which I'm going to call hauntable, and the thing that's visiting it, which is haunting. The hauntable has a simple single function called haunt, and it'll take in a haunt object, haunting object. The haunting is another interface. This is the visitor interface, according to the book, which will have those different interface methods we've seen earlier. Compartment is exactly the same as before. The only difference here is that we're going to make some changes. The first change we're going to do is we're going to make the compartment be a hauntable thing. And we're going to go through all the subtypes and implement that behavior. So what we're essentially doing here is that we are solving the problem of double dispatch with polymorphism. Okay, so I'm going to collapse all that. The room is the same as before. The ghost, I'm going to change the ghost to be Also gonna make some changes. I'm gonna get rid of that default haunt method we had. And I'm gonna make the ghost implement the haunting interface we just added. Okay, and essentially this ghost will be the visitor now. And the only another change I'm going to do is I'm going to go down to the haunt room method, and I'm going to go through each of the compartments and then ask each of the compartments to haunt this current haunting. And the main class remains pretty much the same. I didn't touch this at all. And if I run the program, hey, it works as intended now. So what we essentially did was we've implemented the sort of a type hierarchy that tells the visitor, and we use polymorphism to achieve the effects of double dispatch. For instance, if you add an extra type, right, let's say we have this storage, that thing now you want to be haunted. In this case, when you try to implement it, if you don't handle this haunt implementation on the interface level, it'll throw a compilation error. So we also achieve some level of compile time safety, and if you have more types added, it will scream at you until you handle it. Okay, so with the visitor pattern, we now are able to add new behaviors to objects without sort of changing its structure too much. And on top of that, we've added some compile time safety guards by making sure all the different types are handled. But why? Why are we doing this song and dance? Is there another better way to do this? So let's bring back the same problem we had before. What's wrong about this approach? Well, number one is that you have a little bit of abstraction. What I mean by that is that we have added 2 extra types to deal with our problem, right? Previously, we only had compartments. Now we have these extra interfaces to deal with. On top of that, we've added a lot of boilerplate, right? It looks like first thing is that we wanted to avoid changing structure of the objects, but that's exactly what we did by introducing a parent type, right? We had to change the type hierarchy of our objects. And then we also introduced a bunch of boilerplate that we didn't intend to. It looks like the same. You think you can put it in a base class and call it a day, but the two different of these functions means 2 different things. So we wanted to solve this problem, but we ended up introducing more problems on our implementation side. Namely, we added a bunch of additional types, and we also changed the type hierarchy of our objects in the first place. And this is the worst crime of all time, a bunch of boilerplate that we had to maintain in the next long run. So let's see how we can solve this with Kotlin. So I'm going to rewrite the same exact program in Kotlin. I'm going to use a seal type this time around. I'll explain how this matters in a bit later. And in the ghost class, what I'm going to do is I'm going to stop writing interfaces because I don't like interfaces. I'm just going to write a simple switch statement instead. So similar to the previous, instead of using polymorphism, I'm just going to use a switch statement to dynamically dispatch calls. This is how a switch statement looks like in Kotlin. You have we also call this pattern matching if you're coming from Java world. So we're essentially trying to use pattern matching to solve the problem of double dispatch. So when we get to the room, for instance, if the ghost is given a room, it's going to go through each of the compartments. And there's a nice thing here in Kotlin where Kotlin does this thing called smartcast. So anytime you reference a compartment within this block, the compiler already knows that you're trying to talk about a room, and it's going to allow you to access the sub-properties of that type. And we're also using recursion. So instead of creating another call to a different object, you're just calling the same, it's calling itself. The main program is the same as the Java one. It's nothing different about it. It's more concise because it's in Kotlin. But if you run the program and you get the expected outcome, we've solved the same problem. So since we're using a sealed class hierarchy, meaning that if we, let's say, add a new object type, let's say we are adding a historic object. In this case, the compiler will scream at you saying that, hey, you need to handle this subtype down in this when statement. In Kotlin, all the when statements must be exhaustive. So just without using the visit pattern, just by combining a when statement or switch statement along with the seal hierarchy and smartcast features, we also removed those 3 problems we introduced in the first place. There was no additional types. There's no need for interfaces. We didn't change the type hierarchy. It's all the same types as before. And we also got rid of all the boilerplate. Yeah, so when you're writing Kotlin, you don't actually need to implement the visitor pattern like you do in Java, at least in JDK 11. Okay, so now it's time to head back to the lobby. Now we learned about one of the design patterns, so I'll open up the vote once again. I think out of the 2 remaining ones we have, I think we'll start off at the structural design patterns. And I'll open the next session of voting. So let's jump into some structural design patterns. Here up in the attic, we have 2 different design patterns. On the left, we got an adapter pattern, which looks like we're trying to plug in a non-standard US vacuum cleaner into an Australian plug. On the right, we got a decorator pattern where we're going to decorate this boring-looking attic into something a little more spookier. All right, time to cast your votes. I'm going to jump back to Menti. I think you have to go back. Cast your votes here. Oh. Oops. Wrong slides. There we go. I need to stop clicking this clicker. Okay, looks like we got a little bit of a lead for adapter. Why are you guys clicking on the Android? There's nothing there. It's going to be Android. Okay, I think that's all the votes we're going to get. Looks like the adapter won, so let's jump to the adapter. So let's take a look at the adapter pattern. Again, before we jump on to what exactly the pattern looks like and the implementation details, I want to see what we're trying to solve in the first place. Again, we have a simple sample program. Again, a lot of code. I'll go through all one by one. Up here, we have an adapter, what I'm going to call a plug. Essentially, these are the 2 different kind of plugs you can find. One is the Australian client, and one is the British client that has the 3 rectangular plugs on it. And down here, we have an appliance class. So each of the appliances can have a certain kind of a plug in it, and it can also be either powered on or powered off. And here, I also have 2 different kinds of appliances, like an iron and a vacuum. And also have a socket. This is where you plug in your appliance, which takes in appliance, and also it can be turned on. When you turn on the socket, it'll also turn on the appliance if it has any. I just realized this is going to throw a null-time exception. Oh, well. Down in the main program, I'm just creating a few different objects up here, and I'm creating a socket and then asking, I'm going to plug in my vacuum. But when I try to plug in my vacuum, it'll throw a compilation error at me saying that, hey, these 2 interfaces are incompatible. So this is the problem that we will solve with the adapter pattern. Okay. So without the adapter pattern, we are unable to combine or convert one interface to another kind. And that's the problem that we'll solve. So let's see how the adapter pattern solves this exact problem. So according to the prescribed solution from the Gang of 4 book, an adapter is another class that we write on top all these 3 classes we had before. In the adapter, we have a plug, and it has 2 different kinds of plugs. I'm going to use the template syntax. So usually when you talk about adapters, we have male adapters and female adapters. I'm going to borrow the same terminology. And here, the adapter also extends an appliance. The adapter itself is an appliance and also contains an appliance, which is the thing that you plug in. And then we're also going to override the set powered method. So when you set the power of the adapter itself, it'll also relay that same power to the appliance it's plugged into. Down in the main program, now I also have to create this new adapter and then plug in the vacuum to the adapter, and then finally plug in the adapter to the socket. And when I do that, now I can turn on the socket and it will turn on the adapter and also turn on the appliance connected to it. And that way we allow these objects of different interface types to collaborate with each other and work with each other. So with the adapter pattern, we are able to now effectively convert one type of an interface to a different kind of an interface. Looks good, but why? Can we do this better with Kotlin? If I look at this class, like that header itself kind of screams at me, telling me, hey, that's already a little bit complicated than we started off, right? Now we have this extra wrapper type to deal with that we didn't have before. And on top of that, we also introduced a little bit of indirection. So previously, we were able to directly plug the iron into the socket. All was good, right? But now we have to plug the vacuum into the adapter and then adapt to the adapter to the socket, which introduced a little bit of indirection. So by implementing the adapter pattern, we also introduce an additional wrapper types for us to maintain, and a bunch of different indirection calls that we didn't have before. So what can we do about that with Kotlin? So with Kotlin, instead of introducing a new type, I'm just going to write an extension function. So in Kotlin, we have these nice things called extension functions. In Kotlin, you can extend any arbitrary type with an extension function. So in extension functions, we have this type called the receiver. It's the bit that appears before the dot. That means we can arbitrarily have statically defined functions on top of arbitrary types. So in this case, I'm going to have an extension function called plug, and which accepts a plug of a different kind. Extension functions effectively work as adapters. They are statically resolved during compilation time. And within the function itself, I can create an inner object that is not exposed outside. And this adapter object can just live inside of this function without being exposed to the outside. And it can implement the same behavior as the adapter did. An important thing here is the adapter is never released to the outside. So people who use this extension function doesn't need to know what the adapter actually is. And down here, I'm just going to create one of those adapters and then simply plug in the adapter. All right, so they're looking at the main program. Let's see how we can use the adapter. I'm going to create the same appliances as before. And instead of creating an adapter, I can just simply call the plug method and just plug in the vacuum as if it's the same as like a normal method. If you look at the actual implementation, we haven't introduced any indirection. You can just simply plug in without introducing extra types. So without actually implementing adapter pattern, just by using extension functions, I can just simply solve the same problem of having two different interfaces talk to each other at the same time without introducing extra wrapper types. We also got rid of a bunch of indirection that we had before. So with Kotlin, we don't actually need to introduce adapter pattern. We can just write extension functions and call it a day. Okay. Now let's go back to the lobby and the final, where are we going? We're going to the kitchen with the creational patterns. I was actually hoping this was the other way around because the creational patterns are actually the easiest ones. But, oh well, I should have told that out loud. Okay, and the final part, the creational design patterns. Oh, look at that. We got 2 more patterns to choose from. Let's call a vote. Here. Yeah, cast your vote. We can learn about the builder pattern, or we can learn about the singleton pattern. Ooh, looks like we got a lot of votes coming in for the builder. People are clicking on the cake. Don't touch the cake. Okay, I think the people have spoken, right? Do I need to wait? Could it flip at the last moment? I don't know. Yeah, I think it's safe to call it a vote. Okay, looks like we're going straight to the builder pattern. All right. So again, I'll follow the same theme. What are we trying to solve with the builder? Now, to illustrate this, I have a simple program yet again. Let's take a closer look. We got cake. Everybody likes cake, right? We got a number of layers, maybe some kernels. It could be either gluten-free or it could be dairy-free. And we might have a topper if it's a birthday cake. and some sponge in it. And we also have a constructor that takes those arguments one by one in order to create that cake for you. The main program is pretty simple. We're just creating a cake. We pass those arguments. That's it. What's the problem with this thing over here, though? One issue I see is that since we are making a cake, we have to pass these arguments in the same exact order, one by one. And more importantly, sometimes there is confusion on the use side, right? Like looking at those two Boolean values, you're not entirely sure, is it talking about dairy-free cake or is it talking about gluten-free cake? Which one is it? Another issue we might have is that if this cake, its structure changes over time, and we will have to make some changes to the constructor. The problem with this approach is that from this point onwards, your cake, and people who use your cake builder no longer can use the constructor that you used before, because now we have one extra type to deal with. What we're essentially doing here is we're coupling the internal representation of that object to its construction. So without the builder pattern, the construction requires the arguments to be passed in a specific order, and there is some use side confusion as to which parameter is what. And we've essentially coupled the internal representation of the object to its construction. So let's see how the Gang of 4 book prescribes a solution for this. According to the Gang of 4 book, to solve this problem, you have to introduce what you call a cake builder. This cake builder will mirror the cake object. So for instance, it'll have a single method called build, which will return you a cake. So for instance, the cake had a number of sponge. In this case, it's a required argument, so I'm going to use that as the primary parameter for the constructor. And this way, the builders can enforce the required values. And if you recall from previously, we had a number of layers. And we can also use the default argument here as the sensible default for this cake constructor. And we also have a helper method called setLayers, which the user side can call in order to set different layers. And I'm going to add the two flags we had before, which is the gluten-free and dairy-free. And I'm also going to write two different builder methods for each of those. And that's pretty much it. I'm going to the rest of the functions looks the same way. If I go back to the program, example program, you'll see that I'm going to create a cake here. Before creating a cake, I'm creating a cake builder. And then I'm setting each of the flags that I had before. And then finally, with the build bake method, I guess, I can bake a cake. Since we are using the builder methods, right now there's no use side confusion. You would know exactly what kind of a cake it is. And since they are just method calls, we can simply swap these around and not worry about which sequence we passed in. So using the builder pattern, we essentially made the constructor, the builder can now accept the arguments in any different order. There's no use side confusion as to what parameter is what. And we also successfully decoupled the internal representation from its construction. Why? Why are we writing builders in the first place? So let's do this in Kotlin and see if we can do something better. Well, if I bring back the same previous example, you will see that now in the theme of type abstraction, now we have this extra type for us to maintain. And we also had to duplicate a bunch of internal fields to make the builder work the same way. We also lost some compile time safety guards. For instance, here previously, the number of kernels, if the use side forgets to call this method, we'll throw a runtime null exception, a null point exception during runtime, because we forgot to put that in. So previously we had some compile time safety because it was part of the constructor, but now we've lost it. So we've solved the problems, but again, we've introduced 3 more problems for us to deal with. So let's write this in Kotlin and see what we can do. Here I'm going to write the same exact program in Kotlin. It looks a little more concise, but that's besides the point. And down here, I'm going to write a constructor just like before. But when I do this, the IDE will tell me that, hey, this constructor looks like pretty much all the parameters you have. So you should just nominate this to be the primary constructor. When I click this, something funky looking thing happens. If you look at the braces, now the brace signs are different. This is what we call the primary constructor in Kotlin. It's just a combination of both the constructor and the field declarations into a single declaration. And this is how we use the primary constructor. You just call cake as if it was a function and then pass in all the arguments. Now, you cannot tell me that, hey, isn't this as confusing as the Java example? Like, you don't know what this true and false means here, right? That is true. You don't know that. But this is where another tool from Kotlin tooling comes in. In Kotlin, we have labeled parameters. We can just label all the parameters, and that avoids that confusion. And we can also reorder these. As long as they are labeled, we can reorder them any way we want. It doesn't matter which order you pass them in. Which solved the second problem we had, which constructor arguments needing to be passed in a single order. So this effectively also decouples the order of initialization from its internal representation. If you want to be really fancy, we could also move some of the arguments into the default values. So anytime you create a cake, it'll come with 4 layers, for instance, by default. And you can always override what's coming as a default. Okay. Since we are simply using the class structure, we are still maintaining the compile time safety guards. For instance, if you forget to provide the sponge, this program will fail to compile and will force you to provide the sponge. And let's say the class structure changes, right? In the previous Java example, our cake now have a number of fillings. If this happens, the compiler will tell you that, hey, we are missing an argument. But we can also make it source compatible with any subsequent use sites by providing default values. And that solves that problem. So essentially what we've done is we have one extra problem to solve, because we're still using the internal representation on the construction side, because we still need the same exact stuff as we did before. To solve that problem, we can introduce a secondary constructor, which we can do like that. So just by using a different constructor argument, we can have a different arguments to create a cake out of it. If you want to be really fancy, you can even move the secondary constructor out of the function, out of the class, and into a function that looks like a constructor. And we call these fake constructors, because it looks like a constructor, but it's not. It's just a function. So in Kotlin, just by using the features of the primary constructor, we've eliminated the 3 problems we introduced by implementing the builder path. There's no extra type abstraction. It's just the same class as before. We got rid of all the duplicated fields because there's only one declaration. And then finally, we've kept all the compile time safety guards we had before. So with Kotlin, we don't actually need to write builders anymore. You can just use the primary constructor as it is intended. All right. It's time to finally go back to the lobby. Here we are at the end. So I want to throw some key takeaways out here. I really like design patterns. I think there are vestigials of things that we used to solve in the past, but as languages evolve, we no longer have the same need for the design patterns as we did before. Sometimes some design patterns make sense, so it's up to really us to choose which design patterns we want to implement and see the reasons of them, see the reasons of why. And secondly, let the tooling do the work for you. Don't implement a design pattern just for the sake of it. If you can get the tools to do the implementation for you, just use the tools instead. It's always better to have the tools do the work for you instead of a dev implementing a design pattern correctly. And thank you. Thanks for listening in. And thanks for Dave Leeds for reviewing my talk. He's one of the Kotlin advocates. And also, you can look at the whole talk. There's a whole half of the talk that you haven't seen yet. You can go to the slide deck and explore yourself. Thanks again.
Thank you, Isuru, for the very informative and pretty scary exploration. Does anyone have any question? Please raise your hand. We'll be given a mic.
Any questions? Yes.
Now I can mutter to myself, that's better.
Thank you very much. That was a really great talk. What is your personal favorite design pattern out of all of the design patterns?
My favorite, I would say my favorite would be the factory, which is just a function. I like functions. Yeah, factory would be my favorite. All the questions? We got one more.
We design. Oh, there's one. Yes. Would you say your technology that you're using in your stack influences what kind of tools and patterns you should be using or should have implemented in your environment or anything like that?
Yeah, so I'm coming from the Android background, and in the 8 years I've done Android development, I've stuck with the Android SDK, which is a haunted house of object-oriented design patterns altogether. So we're sort of limited to the framework that you're dealing with. Of course, if you're on your own, you can not do any of these patterns, and you can do your own patterns. In the case of myself, since I'm dealing with Android, I'm kind of stuck with these design patterns, and that's also good and bad, but yeah, it's really limited on which technology. In the case of myself, it was just Java on the JVM. But yeah, if you're on a different stack, there will be completely different patterns altogether.
While I'm walking down that way, since you've spent half your slide deck not showing us stuff, what did you not get to show us that you would love to have?
Oh, the other one I actually liked a lot to debunk, so to say, is the decorator pattern, which I'll give you a sneak peek, I guess, if I can find it. There's a lot of patterns. I sometimes get lost in my own patterns. But the decorator pattern is another good pattern that can be essentially abstracted away with just extension functions. We have these ugly looking use sites that look kind of like, I should have put in some links. Again, all of these are available for you on the slide deck, but it essentially avoids this monstrosity of Java. So here I'm just creating a wrapper inside of a wrapper inside of a wrapper inside of a wrapper to implement a decorator, and things like this can be removed altogether with just using extension functions. Yeah, you didn't get to see this, but in the future you will. Look at all these wrappers.
Yeah, what do you think about Kotlin multi-platform?
Oh yeah, I'm a big advocate. I've done Kotlin multi-platform since the last 3 years. I've actually spoken at KotlinConf in 2022, 23. About Kotlin multi-platform, I'll recommend you check it out. I'm actually using Kotlin multi-platform at work as well, building cool stuff. So I'm a big advocate for it. Jeremy.
Hi, Isuru. I'm your big fan here. Yeah, and in terms of your design patterns, you also mentioned about the factory pattern. And then if you need to build a reusable component, do you prefer to build your own SDK or use another files in your own repository to reuse them, or build a package?
Yeah, the biggest gripe I have with factory is just the fact that it introduced an extra type for you to deal with, whereas all you just really needed is just a function, right? And that's pretty much the reason why I despise the factory as a concept. But in practice, we write functions all the time, so I don't really have a big gripe with that. Cool, question on the front.
Not a question about design patterns, but where are the graphics from?
Oh, I did it myself.
It
No
didn't
AI.
look very AI-ish, so
No,
it's really nice.
It's all assets all the way down. It took me forever.
Very nice.
There you go.
So not only design patterns, but also drawing patterns.
Yes. Will. Yes, I remember you, Will, of course.
But seriously though, those presentation slides are really good. How long did it take you to make them?
I was, actually this talk is actually coming from a different talk. The only thing I did differently this time around is added a few more patterns. I've sort of reused a bunch of assets from previous talks. So it didn't take that long, I was just exaggerating. But this is I themed it a little bit further to match matches and look how I was going first. So it did took me about a month. Yeah. Yep, in the back.
And what about Ktor? Do you use it? Ktor.
Ktor, yes.
Yeah. It's a good option.
Yeah, so for those who are not aware, Ktor is a networking library for both client and server. I've used the client side when I'm working on Kotlin multi-platform. Haven't used the server parts just yet because I'm not doing backend. But if I was doing backend, I would definitely use that. Ktor is a little bit nice because it uses a lot of Kotlin idiomatic features like DSLs, which I quite like. It's very contrast. If you've done some Spring development work in the past, if you compare the two, I tend to prefer Ktor when if I'm running any backend services. Yeah, I'll recommend Ktor.
All right, we have time for one more question if anyone's got one.
Nandini in the back.
I'm getting my steps up today.
So, do you have any thoughts about mixing design patterns?
Well, not mixing per se, but I do like to create my own design patterns and try to try to give it names so it makes sense. But mixing, not really. They're trying to solve a specific problem, and it's never, usually those problems don't really overlap, but I would need to mix two different solutions.
Thank you.
Thank you.